Welcome and thank you for joining us for Rate of Change and Linear Relationships. As always, remember you are in control as to how fast the video goes, in that you can hit pause in order to write down anything that you cannot get as I talk through it. Our essential question for today is, what is rate of change? As well as, what is linear? What does it mean to be linear, and what is rate of change? What I want to remind you of is we had talked about the word rate earlier on in the year, and a rate would compare two different quantities. Now we want to know, comparing those quantities, how do they change? What is the rate that they change? And is it a common rate, a constant rate, or does it differ? And we're going to talk more about that later. So rate of change is a rate that describes how one quantity changes in relation to another. Still written as a fraction. We kind of have abandoned the colon use. And now we're moving on to here. We will refer to it as the rise over run. You may also hear us refer to it as change of y over change of x. And if you have any older siblings who are currently taking any kind of math class, they may talk about delta y over delta x. All of these have the exact same meaning. Alright, so it's this simple. What we're going to do is just find how do each one of these change as it moves on. In this case, what I want you to know, if we were to set this up on a graph, that the time would be our x value and the distance would be our y value. So we want to find, how does it change y over x? The first thing I'm going to do is I'm just going to start and just by subtracting these, or finding the difference between them. So to go from 0 to 1 is a difference of 1. To go from 1 to 2, I'm going to take 2 minus 1, and I get 1. To go from 2 to 3, I take 3 minus 2 and get 1. I got to do the same thing over here. Notice, however, that we're dealing with these negative numbers, and that's typically where we make our mistakes. So for some of you, it might be a wise decision to write the math off to the side. I want to take negative 6 and find the difference between that and negative 3. This is going to remind me to add the opposite, and the answer to that is going to be negative 3. So to go from here to here is negative 3. Then I'm going to do the same thing from here to here. Actually, I'll change colors to show you that one. I'm going to go from here to here. So I'm going to take negative 9 and subtract this, which was negative 6. Add the opposite. I'm going to get negative 3. Alright, last but not least, I want to find this one, which is also just subtracting negative 12 minus the negative 9. When I add the opposite, I get negative 3. So I was able to find that this common change over here is negative 3. That's 1. Remember, we want to find the change in y over the change in x. So this would be negative 3 over 1. That is our rate of change. Let's try another one here. The table shows the number of Spring Fling tickets Imani sold at different times during the school day. Question number 1. Find the rate of change in tickets sold per half hour between 8 and 8:30. So here we're only being asked to find specifics, and we're being asked to find them in the half-hour increments. So how many half-hour increments are there here? Well, there's one half-hour increment. And how many different tickets, or what's the difference in tickets here? So I have to take the 10 minus the 6, and I get 4. This, again, we're talking about a half-hour increment, so that's just one increment. We don't have to do the 30 minutes. So there were 4 tickets in the one 30-minute increment or half-hour increment. But we sold 4 tickets in that time. Letter B wants to know, during which time period was her selling rate the greatest? So what that's telling us is that not all of these are the same, and we should calculate the rest of these. So if I calculate between 10 and 15, I'm going to take 15 minus 10. I found that she sold 5, and this is also a little bit deceiving, because from here to here is 2 half-hour increment times. It's 1 full hour there. So she sold 5 tickets over 2 half-hour periods, which is not as good as what she did up there. And between this last one, we sold 3 tickets, 18 minus 5, and this was also just a half-hour increment. So if I was to compare all of these, we'd go back and say that she sold the most when she sold 4 tickets in 1 half-hour increment. Most of the time, you're not going to have something funny here with this half-hour increment. You'd be able to actually just divide it by the number that's the difference between those. All right, so here we go. We're going to find the rate of change again. We got the value of Johnson & Johnson stock over a 5-day period as shown in the table below. So on day 1, the stock is $66.23. On day 2, it is $68.14. Looks like it went up from day 1 to day 2. On day 3, it's $62.13. Something must have happened because it dropped that day. Day 4, it went up. Day 5, it went up. What this question is saying is determine the rate of change in value between day 1 and day 3. So we're jumping and skipping here. So if I want to find the rate of change between those 2 days, what I'm going to do is I'm going to take the day 3 information and I'm going to subtract the day 1 information. So to go up to day 3, it was $62.13, and I want to take away the day 1, which was $66.23, and so we will subtract those, as well as subtracting the numbers on the bottom. So we don't have to worry about the word days. We're just going to subtract the 3 and the 1, to get a 2. So I know that the bottom number here is going to be a 2, and then I know that I have $62.13. I'm going to take away the $66.23, and I get an answer of negative 4.10. And so what that's telling me is over the 2 days, it dropped $4.10, which we could see just from here. We can tell that it went down. This one wants to determine the rate of change between day 2 and day 5. So let's make some estimations here. From day 2 to day 5, looks like this went up. So I shouldn't get a negative value here. Let's see. I want to take the information from day 5, and I want to take away, oops, forgot the 5. Take away the information from day 2. Day 5 had $72.30, and I want to take away day 2, which was $68.14. We know that 5 minus 2 is 3. Then we just have to take $72.30 minus $68.14, and we get $4.16 in the positive. So that would be the rate of change over those days. Sometimes what they have us do is we find the unit rate if we can. And in this case, it would just be an average because it's not exact. But we could do that by dividing both of these by 3 and finding the unit rate. During a 2-day period, what was the rate of change, excuse me, during what, that's what that should say, during what 2-day period was the rate of change in the stock value the greatest? So I want to know between which one of these did the stock value go up the most. And I think just by looking at it, we'd be able to say from here to here, that sure looks like it's going to go up the most, from 62 to 72. But we could calculate that even by saying, okay, and I'm going to do my work to the side here, that we want to go from day 5 and subtract day 3. And day 5 had the $72.30, and the day 3 had the $62.13. And if I would subtract both of those, we would get 2 on the bottom for the number of days and get $10.17 up on top. And again, I could work at finding a unit rate for that if I wanted to. Be $5, roughly 9 cents in one day. But that was the greatest 2-day spread. We could find the 2-day spread for 1 and 3, which we did right here, and that one went down. 2 and 4 we could look at, but I think most people could common sense say, well, from 68 to 72, that's not going to beat $10. And then we had from 3 to 5, because again, it was a two-day period that we were looking at. Oops, excuse me for that. All right. Find the rate of change. What I would like you to do is, after I read this, to pause it and see if you can determine the rate of change, and then come back and check it for yourself. The table shows the distance, y, that Cheryl traveled in X minutes while competing in the cycling portion of a triathlon. When the data is graphed, what would the slope in the line represent? Really quick before you pause it, remember that slope, and we'll talk more about it later, is the same thing as the rate of change. So what would the rate of change in this line represent? Well, if I was to find this, I would find that from here to here, if I was to subtract that, 90 minus 45 would equal 45. If I was to subtract these, I would have 135 minus 90, which is also 45. Wish I could change that a little bit there. And from here to here would be 180 minus 135, which is also going to be 45. So what we know is that they were taking the time increments every 45 minutes. What else do we know going on here down at the bottom? Well, we know that in one of those 45 increment times, she was able to go a distance of 5 kilometers. And from here to here, she went a distance of 5. And from here to here, that would have a distance of 5. So what is this representing for us? It is telling us that we were able to travel a distance of 5 kilometers in 45 minutes. We could also reduce this, and that would let us know that 1 kilometer could be traveled in 9 minutes. How did I do that? Well, these are just a regular fraction that can be reduced. So I just divided it by 5 to get that, and divided that by 5 to get that. This also lets us know, since it's the same for every single period or every single interval, that it is a constant rate of change. It stays the same. And that's going to come up here in a few more examples. Here's another one. The table shows the key for a map. What would the rate of change be for this data? What I would like you to do is pause the video, try this one on your own, and come on back and watch me walk through it. Go ahead. All right, thank you for joining us back here. Here's the first thing we're going to do. Again, it's always beneficial to show as much work as you can. So what I want to do is find the difference between these, and in order to find the difference between those, I am just going to subtract. So I'm going to take 4 minus 2, and it gives me a 2. Then I want to find the distance between these, which is 6 minus 4, which is 2. And last but not least, 8 minus 6, which is 2. Now I need to do the same thing for the other numbers on the bottom so I can be able to create my rate of change. So on the bottom here, I want to take the 80 minus the 40, and that's 40. From here to here, I go 120 minus the 80, and that is 40. And last but not least, 160 minus 120, and that is 40. If I was going to set these up in a proportion, whether I write it as 2 over 40 or 40 over 2, these are all going to be the same. 2 over 40, 2 over 40, 2 over 40, which would be the same as, will be the same as 1 over 20. And what would that tell us? That 1 inch, because that was what was on top, is the same as 20 miles on the actual road. 1 inch on the map is the same as 20 on the actual road. There are some occasions where you're only going to be asked to find the rate of change within a specific graph. In this case, we want to find the rate of change between 1997 and 2000. In the year 2000, the number was 1,000 average cost. And in 1997, okay, here's 98. There's no 97 listed, but here's a 2000. So if this was 98 and this was 2000, there's only one block in between. Must make that 1999. So that means we're going by 1 year at a time, which means that this is 1997. And so that means 1997 was up here a little bit. We don't have an exact number on it. Excuse me. So let's see. 2000, 1999, 1998, 1997. We'll call that around 1,450. That seem reasonable? We'll try that. All right, then in order to find this, we need to take the year and we need to take the value here. Remember at the very beginning we talked about it being the change in y over the change in x. Here's my y-axis. The y-axis goes up and down like a yo-yo, and the y-axis is all of these average costs, which means I need to find the change in these numbers right here. So I'm going to take the 1,000 minus the 1,400, and then I need to find the change in y, which is the years. Notice here on the x-axis it's the years. And the year 2000 went with the $1,000, so I need to put that here next to the 1,000. And I need to put the 1997 here next to that. When I subtract these, it's going to give me a negative number. It's going to give me negative 450. And down here on the bottom, it's going to give me a positive number, 3, because there were 3 years in between there. And then what I'm going to do is reduce that, and it's going to, 3 goes into 45 15 times, so I'll get negative 150 over 1. And so what this is telling me is that it's negative, so it's going down as I read from left to right, from 97 down to 2000. My graph is declining. It's going down from left to right. Find the rate of change between 99 and 2000. Find the rate of change between 1999 and 2000. Now notice some of these are a little bit steeper than others. Pretend like you're skiing down a mountain. You're going to go fast, you're going to go a little faster, you're going to slow down a little bit more all the way to the end there. So some of these are going to have much larger, much more steep slopes than the other. Here in this case, in 1999, if I was to follow this up, 1999, we'd have a dot right here. You might be wondering why these dots aren't showing up exactly like they did, exactly with these numbers. Let's just say it might be part of your homework. So let's go back to 1999, which lands right about here. We're going to say that's right in the middle, so we're going to call it 1,100 for 1999. And then we have 2002, and in 2002 it did give us that number of 855. So again, what we want to do is we want it to be the change in y, and the y was the money, over the change in x. So let's say this time you picked the 1,100 to go first because you didn't want a negative value. So 1,100 minus 855 is what I would do for my change in y. But then I'd have to take 1999 first because that goes with the 1,100 and subtract 2002. So even though you thought you got away from the negatives, they snuck back up on you. So in this case, this answer is going to be on top 245, if I did my math correctly there. 245 all over 3. Again, that should reduce. I need to just double check here. 245 divided by 3. Turns out to be about 81.7 over 1. So it is going to be a little bit of a different fraction than that guy. Between which two is the rate of change bigger? So this one's going to be negative 81.6 over 1. And this one's negative 150 over 1. So this one, it depends on how you want to define bigger, because it's actually getting smaller. This is a bigger number, but this is a bigger rate of change because it makes it steeper. So that change was a bigger change. It was a faster rate of change. One other thing you're going to need to know about is linear. What does it mean to be linear? Again, take your time, pause the video so you can write these words down as you go. But what I want you to know about the word linear is it has the word line right in there. It's a line. Not a curve, it's a line. So the data points make a straight line on a graph. That makes them linear. This happens because it has a constant rate of change. If I flip back here to this one really quick, this was not a constant rate of change. That was different, 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 different. What we're looking for to be linear is that it's a constant rate of change. They're all the same. When it's increasing, the line has a positive rate of change. It would be positive with a plus in front of it, no negatives. Just as in that last example, if it's decreasing, it's going to have a negative rate of change, and that's why that last one had a negative sign. What's important to know is that I read a graph just like I read a book, and I move from left to right. So what we need to determine here are a few things. One, is it linear or nonlinear? And then if it is linear, is it increasing or decreasing? So remember, to be linear, it has to have a constant rate of change. To have a constant rate of change means I need to find the change in y over the change in x. So I'm going to write it as that triangle y, delta y, over delta x, which really means let's subtract these. So if I take 10 minus 5, I get 5. 15 minus 10 is 5. 20 minus 15 is 5. 28 minus 13 is 15. 43 minus 28 is 15. And 58 minus 43 is 15. So my change in y, all of these were 15 over my change in x, all of those were 5. They were all the same, so they were constant. And since it was constant, that means it is linear, because linear is constant. And then, since all of these are positive numbers, I can tell they're increasing the further I go. This is increasing. All right, let's try this next one. The very first thing I'm going to do is see if it is linear. To determine if it's linear, I take this minus this, well, this minus this to get 2. The difference between these is 2. And same there. Then I'm going to come down to the y value. 12 minus 10 is 2. 16 minus 12 is 4. We suddenly have a problem. 24 minus 6, yeah, this isn't going our way very well, is 8. So if I was trying to come over here and say what is the change in y over the change in x, well, for the first one, it was 2 over 2, right here, 2 over 2. But for the next one, it was 4 over 2. And the last one, it was 8 over 2. So this is not linear. And if it's not linear, we can't tell if it's increasing or decreasing. Find the difference in all of the x values, find the difference in all the y values, put it into the formula and see if they're constant or not. That being said, pause the video, try these two, talk to an elbow partner, see if you got it right, and then come back and see. All right, hopefully you and your elbow partner were able to subtract these and get the answer of 2 for each one of these intervals. You came down here and realized to go from here to here is going to be a negative 16. To go from here to here is a negative 32. And to go from here to here is a negative 48. When I set these up, my change in y over change in x was going to be negative 16 over 2, negative 32 over 2, and negative 48 over 2. This is not linear for this first problem, so I don't have to do the next step. All right, let's try the next one. Hopefully, again, you have your answers already. 8 and 4, the difference is 4. 12 and 8, the difference is 4. 16 and 12, the difference is 4. To go from here to here, I'm going 0 minus 3, so it's negative 3. To go from here to here, it's negative 3 minus 0, or negative 3. And to go from here to here, it's negative 6 minus a negative 3, which is negative 3. So all of these would be exactly the same. My change in y is going to be negative 3 over 4, negative 3 over 4, negative 3 over 4. So this is linear because it is constant. Those are all the same, but it's decreasing because that sign there is negative. Sometimes we can strictly tell just by looking at it. Is this linear or not? Is this a straight line? Well, hopefully you're able to tell me right away that this is not linear. No, this is not linear. Linear is a straight line. This would not have a constant rate of change. Is this one linear? Yes, it is. It does have a constant rate of change. All right, go ahead and write down on your paper 15, 16, 18, sorry, not 17, 18, 19. And you're just simply going to write, yes, it is linear, yes, linear, or no, it's not. And then come back after you pause the video and see how you did. All right, question number 15 is no, not linear. Question number 16 is yes, linear. Question number 18, no, this is not linear. And question number 19 is no, not linear. So in summary, what do I need to know? A rate of change is going to describe how one quantity changes in relation to another. It's also going to be written as rise over run, which is your change in y over your change in x. How does the y change divided by how the x change? Remember that a straight line on a graph is what makes it linear. It's a constant rate of change. And remember, you read a graph from left to right just like you would a book. All right, you do have some homework today that should be on your homework log sheet. It's also right there in case you do not have your sheet with you. Good luck, and if you have any questions, let one of your teachers know.